Our probe has survived a whirlwind of space and time. Now it's inside the supermassive black hole, plunging into a world of unimaginable violence that it can never leave.
Everything that falls into a black hole disappears. And if it never gets out, the question is, where does it go?
Gravity here is so intense, it accelerates space beyond the speed of light. At this speed, the 8-million-mile journey to the black hole's center will take less than 40 seconds, if the probe survives that long.
Now imagine that I'm falling into a black hole. The strength of gravity is going to be different if I'm going in feet first because of the extreme curvature of space-time there. And because of that, my feet will have a stronger pull and you'll get stretched into a form that's reminiscent of spaghetti. So we call it spaghettification.
Spaghettification is real. We saw it happen when Jupiter's gravity spaghettified Comet Shoemaker-Levy 9 into a chain of fragments in 1994. In reality, our probe should be ripped to shreds before it reached the black hole's center.
I mean, of course I could flex and hold myself together anyway, but you know, it's the laws of physics we're battling with here.
Let's suspend those laws and let our probe continue. It's halfway to the black hole's center. From this vantage point, the probe sees everything that's fallen in before it.
If you were talking about the exact mathematical horizon, you would see the entire past of the universe go by. You would see back to the beginning of the formation of the black hole.
According to Einstein's equations, the black hole is a colossal cosmic museum. All the light that's fallen in since the black hole's formation is still here, sped up and stacked in layers. As the probe plunges deeper, the battle between gravity and spin resumes and intensifies.
The centrifugal force gets relatively stronger deeper inside the black hole, and that centrifugal force slows down the flow of space. And the place where it slows back down to the speed of light is called the inner horizon. And all kinds of crazy things happen at the inner horizon.
In this chaotic cosmic blender, matter gets spun around and flung back past the probe.
If I actually jump into a big black hole, just like if I fell down a waterfall, you're going to be perfectly alive and well while you're on the way down. Problems only come when you reach what corresponds to the inner horizon, at the base, where other water and rocks and things come at you.
Deep inside the black hole, the probe hits the inner horizon.
The inner horizons of rotating black holes are the most violent places in our universe.
Wildly energetic particles slam into the probe at near light speed.
The black hole is an amazing kind of particle accelerator at the inner horizon. Particles spewing in all directions, being accelerated through each other. They collide together, they produce enormous concentrations of energy, which vastly exceed any energy in any terrestrial particle accelerator.
These collisions have the power to unleash the most violent events in the universe.
If there is any place in our universe where our universe is making baby universes, where our universe is reproducing, I can guarantee to you that that place is the inner horizons of black holes, because that is the place where the energies that are needed to make a Big Bang, they are produced there.
Did the Big Bang that created our universe happen like this? Was our universe born inside a black hole?
It's actually completely possible that our Big Bang is the remnant of a black hole in some pre-existing universe, crushing things together, then spitting out a baby universe.
One of the reasons black holes are such fascinating objects for theoretical physicists is they may provide a guide to a new understanding of the universe. So if we understand black holes, we may understand the Big Bang. If we understand the Big Bang, we may understand our very origins.
As the probe crosses the inner horizon, everything changes. Gravity pulling the probe inward is equal to the spin pushing it out. The two opposing forces are finally balanced.
So what this creates in the center, in the very region of the inner event horizon of one of these black holes, is sort of like a safe haven, like the eye of a hurricane. And in there, things are a lot calmer, and you can imagine actually navigating once you get through the crazy region on the outside.
Inside this eerie eye of the storm, the probe sets a course for the black hole's heart, the singularity. Ahead lies the end of space and time, the end of everything. Our probe is approaching its destination, the singularity, at the very heart of the supermassive black hole, SAG A*. Here, space, time, and our understanding of the universe end.
Inside the inner event horizon of a spinning black hole, you can look at the singularity. It's over there in a ring. The actual thickness of the ring is 0. It is a circle of points of infinite mathematical thickness and infinite curvature of space-time.
This was once a massive star, crushed down to a point of infinitely small, infinitely dense space and time. Spinning at astronomically high speeds, centrifugal force pushes this point out into a ring, warping the space-time around it.
And it turns out that around the singularity, there's a region where we have what in the jargon is called a closed time-like curve, which is a fancy way of saying you can enter this region, you can zoom around, and then you can come out, and you come out before you went in. So you can basically visit the past version of yourself before you ever entered.
The curved space and time around the singularity create a general relativity time machine. Theoretically, the probe could go back to a time before it existed. But what happens if it travels through the singularity?
There's this idea that a black hole is punching a hole in the fabric of space and time, and then it might be punching a second hole someplace very far away. And then if you fall into the black hole, you will come out on the other side, somewhere light years away, even though it didn't take you any time to traverse that distance. We call this a wormhole because it's like a worm eating its way through an apple.
But could we survive the journey?
What goes into a singularity may come out somewhere else, but what comes out is not going to have much of a relationship to what went in. It will be not only spaghettified, but essentially destroyed. If you want to go somewhere else, take an airplane.
There is another theory, that a singularity isn't a wormhole, it's a white hole.
A white hole is basically a black hole played backward in time. So a white hole is a singularity that sort of spits out into the universe and pushes things away from it rather than pulling them in.
The singularity spits out a universe. It sounds a lot like the Big Bang.
Our Big Bang emerged, at least classically, from a singularity. And it's not lost on people that the endpoint of a black hole is a singularity. Is there a connection between the two? Maybe.
But in reality, this infinitely dense and infinitely small singularity is probably a fantasy.
Infinity, it's popping up in physics, really just tell us that we have no clue what we're talking about. We've never seen anything actually infinite in physics. So my own personal guess is that there are no singularities. And that whenever we see an infinity pop out of our equations, it's just nature telling us that, you were wrong.
Einstein's general relativity commits suicide, if you will, at singularities. It can't continue space-time beyond singularities. How that plays out, don't know. We don't know what happens to it.
This is the end of our probe's extraordinary journey. It has reached the end of space and time, and the limit of human knowledge.
Certainly right now, black holes are the bad boys of physics. They break every rule we know. And that just shows us our own limitations. It's not the black hole's problem. We have not gotten far enough to explain them. And that will continuously challenge us and pull us in a real way into the heart of a black hole.
On our own journey into a black hole's heart, we've discovered it's more than the voracious monster of science fiction. It's a time machine and a cosmic museum. A destroyer and creator of worlds and the universe's ultimate enigma. Understand black holes, and we will truly understand how our universe works.
The math is bizarre, the observations are difficult, and the concepts are mind-shredding. Who wouldn't love that?
I think a lot of people love black holes just because they're big and scary and fun. But we physicists love them also for a different reason, which is that it's the most extreme physical systems that usually give us the best clues about how nature works.
Black holes have driven our imagination beyond where it would have gone before. Nature is much more imaginative than we are. And every time we explore nature, we're surprised. So truth is far stranger than fiction, and the real universe exceeds even the wildest imaginings of the wildest science fiction writer.